Hi everyone, I am excited to talk about the Spark Streaming. Spark Streaming is an extension of the Spark APIs that enables scalable, high throughput, and fault-tolerant stream processing of live data streams. Data can be ingested from many different sources like Kafka, Flume, HDFS, and many other sources. After Spark streaming processing, for example, using the transformation through the data frame and RDD APIs, and the data processed can be pushed into HDFS database or dashboards. Note that the Twitter integration only available through the Scala and Java. For Python, we have to um, work around this, for example, using socket APIs. We'll show you in a minute. So why do we need a Spark streaming? Um, Actually, Spark streaming is very powerful. It is using one stack to do both streaming and batch processing at the same time. Um, it's very different than the other architectures, such as Lambda. And the other tech architectures, they have a separate program flow, um, using the streaming processing for the real-time data and using the batch processing using the big data, but it has a lot of delays. If your application can tolerate about seconds level of the delay, it is better to use Spark streaming because it's scalable and easy to maintain. How the data streams are internally processed within Spark? It is, as we know, Spark work with RDDs. It's resilient distributed datasets. Internally, data streams are buffered and divided into batches of RDDs. Spark optionally, it can only also support window operations. The original data streams are divided by the time interval into 5 different batches, and for the window operation we can define a window to enclose these 3 batches of data, and we can also define a slide interval, shows how often we want to process this window of data. So without this window operation, the data stream Spark stream can only process this separately. With this windows, it looks like just like a memory. So you can have this sliding in. The new time comes in, but you still retain the data in the memory. So you have this all 3 window of 3 batches of data for the processing. Without the window, the batches of data will be just discarded. The reduce by key and window is used for API to perform window operations. You have first you configure the data stream using the window length, define window length and slide interval. Then you call this function with the 3 arguments: the function, the window length, and slide interval. We will show you this in an example. In the coming example, we are going to show you how we stream the live data tweets from the Twitter streaming website and using Spark to processing the stream data tweets and find out the top the hashtags, the most often used hashtags, and we were sorted in a descending order. As we know, as we mentioned earlier, the Python Spark does not support Twitter integration, so we have to use a small program to map the Twitter stream into a TCP socket stream. Let's look at how this is being done. First, we need all these Twitter application API secrets: consumer key, consumer secret, access token, and access secret. We need to go to the Twitter website and register, get all these secrets. I have done that already, and I save it into the environment variable, these 4 environment variables. And I use this to get those stored in this. And then I create an authentication with all these secrets. Now I define a new function called send swiss to Spark. This function is mapping the Twitter stream into a TCP socket stream. So here we define the URL we want to connect to, the query we are using, and then we connect to the Twitter, got the data stream from the Twitter, and then we send it to the TCP socket connection here. This is, we open the local TCP socket and listen to the client to connect. Once the Spark connect here, we find our client, which is Spark, then we're going to forward all the data stream to the Spark. We'll start this program, waiting for the TCP connection. So we wait for the Spark to initiate. So we come here. Here we first create a stream context. The Jupyter notebook I used here have already created a Spark context for you. This is a singleton instance, and we create a stream context based on this Spark context, and we set the batch interval into 5 seconds. Normally you can also set to 1 second level. Since my window size is 5 minutes and my sliding interval is 5 seconds, so I define this 5 seconds. And this streaming context is also a singleton instance. You can hook up to different streams, but there's only one instance here. Once you connect to, so this is the define, we define a TCP socket stream to the local TCP socket, and we define our window size, sliding window, and here we, after we got the data stream, we do a set of transformations basically to get the most frequently showed hashtags and print it out. And the SSC, the socket stream, start connect to the application and start streaming. Let's run the program. We'll see Here we got a live tweets. Here we got the hashtags at the 5 seconds level, and we can see the hashtags are sorted by its frequency and descending order. I hope you enjoy the show, and give me some comments if you have any questions. Thank you very much.